this order we'll learn about Poisson distribution. So Poisson distribution was named after French mathematician Simon Denis Poisson. Now, what is probability mass function of Poisson distribution? Firstly, why probability mass function is defined? There are two types of function. One is probability mass function. Another one is probability density function. Probability mass function is defined for discrete random variable, whereas probability density function is defined for continuous random variable. Now, what's discrete random variable? Discrete random variable is a variable that can take value that are only discrete in nature. That means it can take value of 1, 2, it can take 3, it may take 4, but it cannot take 1.5, 2.5. So this one is the graph of discrete random variable. Now for continuous random variable, it can take any value from 0 to infinity. So it belongs to value like 0, 1, 2, 3 up to n, whereas it does not belong to value like 1.2, 1.5. In case of continuous random variable, it can take any value 1.5, 1.2, any value. It may be decimal or integer. So these are the difference between probability mass function and probability density function. So Poisson distribution is defined for discrete random variable. That is why probability mass function is defined for the same, which is P of x equal to e raised to minus lambda into lambda raised to x divided by x factorial, where lambda is mean rate of success and x is required number of success. That means it can take value, it could take value like 0, 1, 2, as we have discussed in earlier. Now parameter of the distribution is mean rate of success, that is lambda. Mean of Poisson distribution is equal to mean rate of success, and standard deviation of Poisson distribution is square root of lambda. That means mean equals to variance equals to lambda. This is easy to remember for Poisson distribution. Now let's see the real life examples of Poisson distribution. First example is number of defective bolts produced by a reputed company. Second one is number of printing mistake per 10 numbers of page. Third example is number of complaint received per 2 hours. The time can be anything. I mean, it can be 1 hour, it can be 2 hours, 3 hours, or 12 hours. Fourth one is number of bikes crossing at certain point per minute. And fifth one is number of suicide reported in a particular city. So these are the example that makes Poisson distribution to understand in easy way. Now what are the conditions? How to identify the Poisson distribution? The first and foremost condition is that the number of random variable has to be discrete in nature, as the distribution is defined only for discrete random variable. The second condition is that number of trials should be large. Ideally it has to be infinity, but practically we can say that number of trial should be large. The third condition is that probability of success has to be very low per trial. The fourth one is that sigma has to be finite. That means mean rate of success has to be finite. And the fifth condition is occurrence are rare. Here we can see that if occurrences are rare, then probability of success will be very low. That means, for example, we have seen that number of defective bolts produced by a reputed company can be defined by Poisson distribution. Here number of bolts that are defective are very low, as the company is reputed. Hence the event that number of bolts will be very low is very small in nature. Now let's understand the basic difference between binomial distribution and Poisson distribution. So here are the few key differences. Let's divide this part in binomial distribution and Poisson distribution. What are the differences? The first difference is that binomial distribution is biparametric. As we have seen that it is in video of binomial distribution that it is having two parameter, one is n, another one is 2, hence it is biparametric, whereas Poisson distribution is uniparametric, having only one parameter, that is lambda. Now number of trial fixed, that is n is fixed at certain value, whereas in case of Poisson distribution the number of trials are infinite. Third example is that there is only two possible outcomes. In case of binomial distribution, whereas for Poisson distribution there is unlimited number of possible outcome. For example, in case of number of printing mistake per 10 numbers of pages, the number of printing mistake can be anything. We cannot say we cannot say that it is having only two outcomes. It can have any number of outcomes. So it is unlimited number of outcomes it is having. Another key difference is mean is always greater than variance. As we have seen in the video of binomial distribution, that mean for binomial distribution is NP and variance is NP into 1 minus P, whereas in case of Poisson distribution, mean equal to variance equals to lambda. If you write an example, then it is having experiment of tossing a coin, and here we may write that number of printing mistake. So these are the few key differences that are exist between binomial and Poisson distribution. Now let's see the solved example of Poisson distribution. We have seen in our previous video that binomial distribution is having following the we have solved in previous video the examples of binomial distribution. Now here the example is given as an electronic component produces an average of one error per 10,000 hours. What's the probability of an error if a part works for 20,000 hours? Now here we need to know that in general for Poisson distribution problem we are having mainly two challenges, mainly two key factors for obtaining the answer. The first is what is the mean rate of success, that is lambda. Another thing is interpreting the value of values in probability mass function. So here, how to identify the mean rate of success? We can see that the mean rate is already given, but it is having time period associated with it. We must anticipate into this. So mean rate of success lambda equals to 1. What's the required time period? That is 20k hours, 20,000 hours. And one is given for 10,000 hours. So our final mean rate of success would be 2 errors per 20k HRS. Now considering the Poisson distribution, the answer can be obtained as P of x equal to 1 equals to e raised to minus lambda into lambda raised to x divided by x factorial, where x equals to 1. That implies e raised to minus 2 into 2 raised to 1 divided by 1 factorial. If we simplify this, then our final answer is 0.2707. Now let's see another example. We may see that it is having only two challenges. One is identifying mean rate of success and another is interpreting the value in probability mass function. Now second example is average of 8 customer enter NTC bank every hour. Use Poisson formula to calculate probability that certain 1 hour period A part 3 or more customers came into the bank. B part exactly 5 customers came into the bank. So in both the case, the mean rate is given as 8 for 1 hour and required period is also 1 hour. So mean rate is same for both the case, that is 8 customer per hour. A part, this one is for B part, lambda equal to 8 customer per hour. Now P of x greater than or equal to 3 is equals to 1 minus P of x less than or equal to 2, which is equals to 1 minus sigma x equal to 0 to 2 e raised to minus lambda into lambda raised to x divided by x factorial, which is equals to 1 minus sigma x equal to 2 to 0 to 2 e raised to minus 8 into 8 raised to x divided by x factorial. If we simplify this, then it will be equal to 1 minus 0.0138, which would further be equal to 0.9862. So answer for the part A is 0.9862. Now what's about part B? Part B, exactly 5 customer came into the bank, hence P of x equal to 5 equals to e raised to minus lambda into lambda raised to x divided by x factorial, where x equals to 5, which would be equals to e raised to minus 8 into 8 raised to x, 8 raised to 5 divided by 5 factorial. If we simplify this, then final answer would be 0.0916. So our answer to part B is 0.0916. Through Breatter application, this question can be solved only in 3 steps, which is depicted here. Firstly, we need to select from home screen the distribution as Poisson distribution. It will be navigated to data entry page, where we need to enter the average rate, mean rate of success, required number of probability and types of probability. Click on the submit button. It will navigate to this page where final answer is obtained through step-by-step manner. For part B, the similar step is followed. Select Poisson distribution, enter average rate as 8 and random variable as 5. Select type of probability and click on the submit button. And the final answer is obtained in step-by-step manner. So our Breatter app is available in Play Store. You may download it. It is also available in App Store. We are also having one website, that is www.breatter.com. We are also available on page on Instagram. You may visit it. Thanks for watching the video.